Okay guys, welcome back to part 2 of difference of squares. So after the first video you might think like, what else could there be? But there is one important step that does sometimes come up, actually a lot of times, that I didn't talk about a ton in the first video. I wanted you to just get good at it first. And now it's time to show you that most of the time when you see things, if you try and take a square root, you won't be able to get a square root. Like when I look at this first example, the square root of 2, that's some decimal, and the square root of 72, that's also a decimal. So oftentimes, a difference of squares will not work the very first time that you look at a problem and try and do it. So remember that the first step in the last video was always to look for a GCF first. And in this video, when we find a GCF, you'll be able to take it out and make things work. Now I will say, in the real world, sometimes when you take out a GCF, it still may not work, and that just means maybe you can't factor any further. But in this week's video, when you take out the GCF, it'll usually work. Alright, so let's look at this first one. Obviously, we already talked about that I can't take the square root because there is no such thing as a whole number for the square root of 2 or square root of 72. You'll just get decimals. So instead what we need to notice is that we can divide both of these numbers by 2, which means let's take it out as a GCF. So if I divide the first one by 2, I just get x squared because, well actually let me write that back in, because those 2's cancel. And if I divide 72 divided by 2, I get 36. So now let's see if I can take the square root of both of these. Just the part that's inside of the parentheses. So square root of x, that'll work. That's just going to be, or square root of x squared, I meant to say, will just be x. And I did go through this fairly quickly in the last video, but I'm hoping that's something we know. If you square something and then you square root it, those are opposites of each other, and so they cancel out. So over here when I'm doing the square root of x squared, that square and square root cancel, which is why my answer is just x. Okay, so now let's do the square root of 36, which is 6. So this worked. I found a square root of both of them, and now I'm going to use x and 6 to make my parentheses. And remember that one of them you add and one of them you subtract. It doesn't matter which one goes first. Since I had a GCF on the outside, I still have to write that, and then now that's my final answer. And that's it. So the only thing really different with this video is just reminding you to take out that GCF, and we're going to actually have to do it this time. Okay, let's do a few more. If I just start trying this and take the square root of 18, I'll get a decimal. So this is not working. So instead, let's see what GCF there is between 18 and 50. So just thinking this through, factors of 18 are, let's see, it can divide by 6, it can divide by 3, it can divide by 9, and it can divide by 2. I don't think 50 is divisible by 6, 3, or 9, but I do know that it's divisible by 2. So let's divide both of these things by 2. And what would we get is we would get, so when I take out the GCF, I would get 9x squared minus 25. Okay, now let's take the square root of both of these. So take the square root of 9x squared, so square root of 9 is 3, square root of x squared, you just get x, and the square root of 25 is 5. Okay, so now we can, with my GCF 2 still on the outside, I can write my two sets of parentheses using these letters and numbers. So 3x plus 5 and 3x minus 5. Again, it doesn't really matter what order these parentheses are written in as long as you have them both. And that's it. Okay, let's look at number 2. Again, if I just take the square root, I can't do that. There is no square root of 45, that's a whole number. Same thing with 20. So instead, let's take out a GCF. I'm noticing that both of these you can divide by 5, so let's take 5 out and see what would be left. Oh, the other thing I'm noticing, I just noticed this, I have a b in both terms, so let's take out a 5b actually. So what would be left is 9b squared, I would drop down by 1, and then in the other one, it would be minus 4, and there would be no b because I already took it out right here. Okay, so now let's take the square root of everything inside the parentheses, and what would I get? I'm still going to write my GCF on the outside. The square root of 9 is 3, and the square root of b squared is b. and the square root of 4 over here is 2. So I know that my numbers are going to be 3b and 2, one of them with a plus and one of them with a minus. And we're done. Alright, let's do the third one now. If I just try and take a square root of 8, not a thing, square root of 32, not a thing. Well, it is, you just get decimals. So, let's take out a GCF. 32 actually divides by 8, so I'm going to take out an 8. But not only that, but I have a y here and a y cubed here, so I can take out a y from both. And then what would be left? In the first one, I would get just x squared, and in the next one, I would get 4y squared. Okay, so now let's take the square root of both of these on the inside. I still have the 8y on the outside. And then now with the difference of squares rule, let's see, square root of x squared is x, square root of 4 is 2, and square root of y squared is y. So my numbers and letters are going to be x and 2y. One of them a plus, one of them a minus, and you're done. Okay, let's look at the last one. Same sort of thing. I can't take the square root of 24. I can't take the square root of 54. So let's look to see if there's a GCF. I definitely see, since they're both even numbers, that you can divide by 2. But let's see, is there anything else I can divide by? I know 24 divides by 6. Does 54 divide by 6? Yes, it is 9. 9 times 6 is 54. So that means I can take out a 6 from both of them. This has the letter A and this has the letter B, so they don't have any letters in common. So what would be left? 4a squared for the first term minus 9b squared for the second term, if I divided them both by 6. So I still have my GCF on the outside, and then in my parentheses would be whatever the square root of both of these things is. Square root of 4 is 2, square root of a squared is a, and then square root of 9 is 3, square root of b squared is b. So this is going to be my numbers and letters, and one of them put a plus and one of them put a minus, and you're good to go. Alright, so one other thing I want to show you is, I'll show you in this example. So if we were to do this, take the square root of both of them, square root of x to the fourth, just a quick recap from the first video, the square root is the same thing as the 1/2 power. So if I have x to the fourth, and then instead of writing a square root like that, what I could do is just do a 1/2 power. And then you multiply these together. 4 times 1/2 is 2. So the square root of x to the fourth is x squared. Another way you can think about it quickly is just divide the exponent by 2. Okay, so I am getting x squared, and then the square root of 81 is 9. So I know that my two parentheses is going to be x squared plus 9 and x squared minus 9. And remember, it doesn't really matter what order you write that in, as long as you have both parentheses. Okay, now I can't do anything with this one because there's a plus sign. And so it's not a difference of squares. But if you look at this one in red, I have a minus sign here, and I could still take the square root of both of those things again. So let's do it. Let's leave the yellow one alone. So that was x squared plus 9. Since it was a plus, we're not doing anything with it. So that one's staying the same. Let's look at the red one. The square root of x squared is x, and the square root of 9 is 3. So that one I actually could break apart. This term right here can break apart into these two by doing difference of squares again. So this slide is just up here to show you that sometimes when you do difference of squares, you might be able to do it again on just one of your factors. So keep that in mind. So in this example, this down here would be my very final answer. Alright, let's practice a few of those. If I take the square root of both sides, there's no GCF notice because this is an R and this is an S, so they definitely don't have anything in common. And if I take the square root of both sides, I would get R squared minus square root of 16 is 4, square root of S to the fourth is S to the second. Okay, so that's great. And so then I know that my factors are going to be R squared minus that and plus that. So I've done my normal difference of squares. Now, if we look at just this one in yellow, since there's a subtraction sign, this one in green I can't go any further because this is a plus sign. So difference of squares will not apply because it has to be a difference, a subtraction sign. I could take the square root again of both of these and I would get r, and then let's see, square root of 4 is 2 and the square root of s squared is s. So I can fill it in with a plus and a minus using those numbers and letters. And then this green one right here, I still need to write that, r squared plus 4s squared. This is still going here. I can't just get rid of it. It was always there. It's just that I couldn't go any further with it. So this ends up being my final answer. All right, let's do one last one together. If I take the square root of both things, I would get, let's see, what's the square root of x to the 4th? X squared. Square root of 1 is 1. So my numbers and letters are x squared plus 1 and x squared minus 1. This one I'm done because there's a plus sign. So I'm just going to write that again. I can't do anything. I'm not going to change it. But this one here in green, since it was another minus, and I can take the square root again, that one's going to break into 2 more. Square root of x squared is x, and the square root of 1 is 1. Put a plus sign in one and a minus sign in the other, and now you're done. Okay, and that's it. That's the last thing I wanted to go over is just that if you do difference of squares, keep in mind that sometimes you might end up doing it twice because one of your factors might allow for difference of squares again. All right, and that's it for this week, you guys. Have a great weekend.